Alright, okay, so yeah, I'll talk about all of that stuff in a second, but first I want to welcome all of you. Let me move this over. Welcome to the class, EGME 306A. Yeah, fancy mic, and Zoom is finally better with audio quality, I think. So hopefully it sounds okay. Last semester it would like clip a lot. It was annoying. Anyways, so welcome to the class. I recognize some of the names in here from having you guys in a different class before. But for everyone else, welcome. My name is Patrick Phelan. I'm a grad student here at Cal State Fullerton for mechanical engineering. And yeah, it's my last semester. So if you were planning on having me or avoiding me, I don't know, for next semester for 306B, I'm not going to be on campus anymore. So it's your last time. Let's see what else. I will get the main question out of the way, even though I just talked about it, but in case anyone came late, we're only gonna ever meet on campus if we are having a lab. So that's the only time. Even for the final, I'm planning on that being online as well. So all of our lectures are gonna be online on Zoom, and then all of the labs are gonna be in person. And for that, we're gonna first meet in the classroom, and then we're gonna walk over as a class to the lab. But it's right next door, literally next door. Okay, so hopefully all of you guys already checked out Canvas. I just found out from my section earlier today that you can't see any of these images on the Canvas homepage. So I need to fix that. Basically, I imported, my course from a different section into these other two sections for today, and the images didn't transfer right. So I'll fix that sometime today. So today is going to be pretty relaxed. Oh, by the way, before I forget, you don't need to call me professor. I'm not a professor anyways. You can just call me Patrick. Fine with that. Okay, so today's going to be pretty relaxed. We're just going to be going over the course. We'll go over Canvas. We'll go over the syllabus. And at the very end, it's going to be real quick, so don't worry. We're going to go over how to get dark mode in Matlab. I know some of you've already watched me do this in like last semester, but we're going to be using Matlab in this class as a class. So I'm going to show you guys how to get dark mode because a lot of people like that. Okay, so I think everyone knows this, but if you log into the Fullerton website and you go on the home page here, you're going to access our course page by clicking on Canvas up here or on the left. I'm using the new portal that they have, but if you have the old portal, it should be on the left here. So click on Canvas. Our class, we're over here. We got Bender. No real good reason why I have Bender as the course image. It's something that's not boring. Basically, that's why. Okay, and this is the course homepage. So again, I'll fix the images. You guys can't see them right now. I'll fix that. Okay, question. Will I be taking any waitlisted people? Yeah. I usually try to take everyone I can take. And it's been okay every time. So I think they like to have other people go in more open sections, but I think a lot of the sections are waitlisted anyways. So long story short, yeah, I can add waitlisted people if he wants to join. Yeah, okay, yeah, if they're waitlisted, yeah, you can't access Canvas yet. But that'll be probably sometime next week you can access it. I just need to tell the department that I want to add you guys. But I did send out the email to everyone for today's Zoom link. Okay, so on Canvas, I uploaded some slides. I usually don't use slides for this class, but I did for today. So you can access them. Let me just pull this up. Okay, so you can access these slides by going to, you can click on this image. I know you don't have an image, but you can click on the box, and that will take you to the entire kind of module that we have for the first lab. So that'll be over the first 3 weeks. I guess really weeks 2 and 3. So click on week 1, and also you can see this breakdown. I'll do this every time where I show for each week if it's going to be in person or if it's going to be virtual. So week 1, obviously it's virtual. Hope you like the Facebook mom kind of image here. And I'm always going to have any files that you need to have. I'm going to post the lecture video that's going to be uploaded on YouTube. And then I'll have the schedule here as well. So, slides right there. So let's open these up. What we're going to do first is, actually, let me quickly, just in case, I'll go over Canvas a little bit more just so everyone knows how to use it for my course. So let me go to Student View. Okay, so this is what you guys see. So I'm going to fix the images for the 10th time. And all of the important links that you need are up top here. So the Zoom link for lectures, it's always going to be the same. So just click on that. Office hours, they're on Zoom. They're on Mondays at 11 a.m. I'll talk about that later. It's always going to be this Zoom link. You can access the syllabus. If I ever update it, it'll be updated on Canvas too. My contact info is here, so you can get my email. Discord, a lot of you, I think, I don't know, maybe half of you already on the Discord server. I'll talk about that later too. YouTube link that goes to my channel. I'll have a playlist just for this class, so you can access all of them there, all of the lectures. And then VKS, we'll talk about that a bit later as well. So everything here it's broken up by lab. Okay, we have 6 labs for the semester, so each box corresponds to a lab. So we'll click on this lab, which is going to be for the first 3 weeks. I have a page for each week, so it's kind of organized like that. And if you want to access anything like lectures or any other files I upload, you can go by week, or what I personally think is easier, click on Files over here on the left, and I'll have a folder for each lab that we have. And I have a folder for the syllabus, any lecture slides that we have. It's probably only going to be for today though, but everything will be organized here as well. Okay, so now let's open up the slides. So we're going to start out today by, here we go. Let me make this bigger. That's not what I wanted. Okay, I know what happened. Sorry. Let's hide that. Okay, there we go. So we're going to start out today by going over some of the labs that we're going to do this semester, just to give you an idea of what they are and how they look, basically. So we already talked about, when we're in person versus online, and I'll always post it on Canvas. And I do want to say that if you're sick, whether that's just any illness or especially COVID, don't go to lab. I want everyone to always go to lab if they can, but if you're sick, of course, stay home. Contact me, tell me that you're sick, and we'll try to figure out if you can make it up in person. And if you can't, you can still do the actual lab memo that you have to do, but you won't be able to do the experiment in person. So hopefully that doesn't happen, because I don't want you to pull a Tina where you're kind of at home trying to get this lab experiment experience. That's just not going to be nice. I want everyone to actually do every single lab in person, because you get a lot more experience that way. Canvas. So lecture recordings, they're going to be uploaded there. I'm also going to upload the lab data there. So we're going to do experiments in person, right? And basically, it's not really me, but the lab instructor doesn't want any students to bring in a flash drive of their own. He's always worried about malware going on the computers, so we're just going to avoid that issue. Don't worry about the lab data. I will have my own flash drive that's given to me, and I'm going to collect the lab data from every workstation that we have in there, and then I will upload that onto Canvas that same day. Okay, and then the lab memos, they're going to be uploaded on Canvas by you, and I'm going to grade them on Canvas as well. All right, so for the experiments. So for our first experiment, this will be in week 3. It's going to be called stress and strain, and there's an emphasis on what's called the extensometer, which is this tool that you see here. So the kind of big picture for this experiment is we're going to have 3 different materials, aluminum, 1018 steel, and 1045 steel. You can see they're all going to be rods like this. And we're going to secure them to this machine. It's called the MTS Insight Tensile Testing Machine. It's a really long name, right? So we're going to use this machine, I think, for 5 out of the 6 labs. So we take our rod and we secure it to the machine. You can tighten it down with these jaws here. And attached to our rod, we're going to have this extensometer. So basically what happens is we start applying tension to this rod, it's going to elongate. And this extensometer is going to elongate itself at the same rate as the material. And that elongation is being transferred from this wire to a computer. I also forgot, you guys can't see my mouse, can you? My section earlier said they couldn't see it. So I'm like saying, I'm trying to point stuff out, but you can't see it. Oh, you can see it. Okay. Maybe it's just a weird glitch earlier. Okay. So yeah, so that data is getting transferred to the computer, and basically at the end, we're going to get a stress-strain relationship where we can calculate the elastic modulus for each material, and we're going to compare that to a published value. Now, I think some of you have taken EGME 331, which is the stress mechanics class. Some of you are probably taking it right now, so some of the things I'm talking about, maybe you haven't got to yet, or maybe you're just getting to that this week. I think in general, that class is pretty synced up with the lab. I think at one point, once we get to the column or something like that, it starts to get a little out of sync. But of course, we have lectures too, where we go over some of the theory, but not as in much depth, right, as your actual class. So that's experiment 1. And when we break this, it's really loud, so that's why I'm telling you guys here in the slide. It always surprises people how loud it is. It's almost like a gunshot or something when the material breaks, when it breaks in half. So just be prepared for that. All right, so then experiment 2 is pretty similar to experiment 1. It's almost the same. You see that we have a material here, I think it's aluminum. And for this experiment, we actually aren't going to break it this time because you see we have another tool, I guess, that's attached to the material. So this is a strain gauge here, and we're still going to use the extensometer, but we're going to use both of these tools at the same time so they can both be used or utilized to measure strain. And so we're going to use these 2 different methods, and from that, we're going to see which one is basically more accurate. All right, and by the way, how this works, this strain gauge, it has some really small resistors on there, so little changes in the electrical resistance, it's converted into strain, into a reading for strain. Okay, and then lab 3 is called the beam. So you can kind of see here that this is an I-beam, and what we have is it's simply supported. So we have a support on the left and a support on the right, and then in the center of the beam we have 2 equal loads that are being applied here. So what's going to happen, let me get my really fancy prop. Okay, here we go. So we got our beam, we apply the load in the center, and let's make it even. It bends, right? Really nice. Okay. And what we're going to do in the lab is we're going to measure that maximum vertical deflection, which is going to be in the center. And we're also going to measure the maximum bending stress that's going to occur. So we're going to do that. We're going to measure the deflection with this tool right here. there's a little nub in the center that's going to measure that change in its position. So that's really simple for you guys. And we're going to also calculate in the end the elastic modulus. And we're going to use that then to get the bending stress. So we're going to compare our theoretical results to the experimental results. And for this one, we're not going to break this either. That would be kind of insane for this. Software that we have is going to limit the loading that's applied. All right, column 4, or lab 4 is the column. And this lab historically is kind of a huge pain in the ass. We'll see if it's better this semester. Basically, I mean, there's a lot of things that can go wrong. So you look at these fixtures that we have. A lot of times these fixtures, they get damaged and it messes the experiment up. So it's really annoying. But I do know the last time we were in person, the lab technician was trying to get better materials for these fixtures so they wouldn't break as often. And also, one of the main components of this lab was measuring the deflection, so how much a column is going to deflect outwards. Okay, so we have compression going down, and because of that compression, at some point, all of these columns, they're going to deflect outwards. So one component is, again, measuring that deflection, but especially for these really short columns, it's hard to find that plane in the beginning where it starts to deflect out. So a lot of the readings are just kind of crap, to be honest. And in fact, a lot of the instructors don't even do that part of the lab because it's just so inconsistent. So often what we do instead is we get these aluminum rods, they vary in length, and for all of them, we apply a compressive force, and we keep applying that force until it can't increase anymore. At that point, that column has failed, and we look at that critical load that all of these columns were able to take, and then we'll classify how they failed. So that'll either be by crushing, or it'll be by stability failure, or it might be a combination of both of those. So of course, we'll talk about all of this theory, so it actually all kind of makes sense later on. Okay, lab 5. I think a lot of people like this one the most, probably, just because it's pretty cool, and you can see some pretty cool fracture surfaces that we'll talk about. So for this one, we have 3 different materials. Again, like a lot of the labs. So we have aluminum and 2 different steels. And the specimen that we have is maybe like an inch long, and it's notched. We'll talk about why once we get to that lecture. But basically, we take these materials and we place them down here. And once we place them down there, we'll load up this pendulum up high, and it's like 60 pounds or something. So make sure you're using good form, or you have 2 classmates lifting this up. And you'll lock this in place, and eventually what we'll do is we'll release that pendulum. It's going to strike that material that we just put down there, and it's going to break it. The more interesting thing for this lab is that for the material, it's subjected to a really big range of temperature. So at the lowest, it's going to be in liquid nitrogen. At the highest, it's going to be in an oven. So you want to take it from that environment, and as fast and still safe as you can, you want to put it down on this test apparatus, and then you do the experiment. And what we see here on the front panel is it's going to tell us how much energy each of those materials absorbed. So from that, we can tell how much each of these materials is impacted or affected by changes in temperature. So some of these they're going to be impacted quite a lot by differences in temperature, and some of them won't be. So, whether they're really cold, right, and they're immersed in liquid nitrogen, or if they're really hot from the oven, I think they will absorb right around the same amount of energy. And yeah, so we're going to take note of the fracture surface. So for that, we have a kind of macro camera in the lab, and we'll look at that fracture surface after we broke it. So if a material can't absorb much energy. It's going to fail. It's going to act like a brittle material. That surface is going to be like a really clean cut. But if it's really ductile and it absorbs a lot of energy, then it's going to have a really rough surface because it's like withstanding a lot of that force. All right, and then the last lab is the double shear lab. So again, we have 3 different materials. Different this time, we have copper, which we never had before. But we have 3 different rods, and we place them inside of this fixture here. And this part up here, it applies a downward force, and from that, this rod is going to fail along 2 planes from shear. Okay, it's going to shear right here and right here. And from that, we're going to see which material can withstand the most amount of force or shear force. And we're also going to look at that fracture surface again with that macro camera. So something like copper, it's going to look, as we call it, like really smooth. So it's gonna, or smeared. So it's gonna look almost like peanut butter kind of. And something like aluminum or steel, it's not going to be quite as smooth as that. Okay, so anyways, those are all of the experiments that we're going to do this semester. I just want to give everyone kind of a sneak preview as to what we're going to do. So you don't just show up on the day of lab and kind of wonder, what are we going to do today? Also, someone asked me in my past class if you can take pictures throughout the lab. Most definitely. You could take video, you could take pictures. And in fact, pictures can be pretty good as a supplemental kind of source or whatever on your lab memo. You won't get more points or anything, but it's good, it's helpful. So before we move on, are there any questions on any of the labs that I can answer now? Okay. I also had a question last class about groups. So you're going to do the lab as a group. We're going to have 4 groups of 4 to 5 people per group. Actually, maybe even more than 5 if there's more than 20 people in this lab. So it'll be groups of about 5 per group. We'll say that. And I'll let all of you guys pick your groups before we do our first lab. So remember, we're going to meet in a class, and then we're going to have you guys pick groups there, and then we'll head over to the lab. Also, I forgot to say, our class number is E42, so that's right around the quad area for the computer science and engineering building. So if you walk around there, you'll see E42. It's kind of by the gastronome, and then right next to us is the lab. Okay, so before we talk about Matlab, we're going to go over VKS and then the syllabus, and then we'll finish off with Matlab. So if you go to Canvas, okay, hold on. Let's put that. Gotta hide some stuff. We'll close out of that. What was that?
Oh, I was just gonna ask real quick since we're using pretty much for the same kind of tools for the or the same. I think you said 5 out of the 6 labs.
Mm-hmm.
Is the I mean, what are we? Does each lab serve a different a different purpose, or are we checking for stress on all of them for just these materials? Or
Yeah, it's a good question. So for a lot of the labs, we're looking at stress, just for most of them probably. So the first lab is doing a tensile test, and the second lab is also a tensile test. But then the third lab, that's different because now we're looking at bending stress. Fourth lab, different, we're looking at compressive stress. But all 4 of those so far, they have that thing in common. They're all dealing with stress, but different kinds of, or different type of stress. Fifth lab, that's really different than any of the labs. That's looking at energy and toughness. And then the last lab, again, that's another kind of stress. We're looking at stress again, but this time from a point of shear stress. So we're using the same machine, but it has different like fixtures on it to do these different tests.
thank you.
Mm-hmm. Okay, so if I go to the homepage for Canvas, I'm going to click on VKS, which was developed a few years ago now by Dr. James and another grad student. So for each lab, I'm going to give you a lab handout that's from the department, and that will have a list of procedures for what you need to do for the lab. But VKS is this online website that you can look at. So you can look at the procedures on a website. So it gives you a much better idea of what you have to do. So the login for this, if you click on the module for this first lab, I might put it somewhere else on the course just so it's easier to access the login. But if you click on week 1, then you get the login down here. I did not make the username or the password. I know it's like, that's not secure at all. But anyways, get them there. Go to VKS, you can log in. And for 5 out of the 6 labs, we have these online procedures. So we don't have it for the 5th lab. That's the Sharpie Impact lab. But you don't really need anything for that anyways. It's a pretty simple lab. So I'll give you a preview of what this looks like. So what you do is you click on View. And we'll do Test, Proceed, and New. You gotta click so many things, it's kind of annoying. And then Start. And then, so for an example for the first lab, I won't go over every image, of course, right now. We'll do that probably next week or something. So we'll look through, and there's a lot of pictures, and it goes over every step of the procedure that you have to do. This is a good view of the machine, by the way, so this is what you're going to be using in this semester. So the computers have been upgraded. I just found out about that a few days ago. So you don't have these really old looking, like 2002-ish like looking monitors here. Got some new nice ones. And also the software in the computers, that's been upgraded as well. So I haven't seen this in person yet, but it looks like the software is actually pretty different. At least the UI is. So I'm not sure how much this VKS site is going to help software-wise, but the actual physical procedures and setup, definitely you can use this website still to get a good idea of how you need to do everything in the lab. So once we get closer to the first lab, I'm actually going to go inside of the lab room myself, and I'll take a look at the software to see what the difference is. But either way, I'm with you guys in the lab when you're doing the experiment. I'm there to help you if you have questions, so no worries about that. Alright, so yeah, there's quite a lot of images here. Again, it's really detailed, so I would have loved this if I had this when I took this lab myself. It's great. But you will, of course, still have the actual PDF handout that I give you that's from the department. All right, so any questions on VKS? Okay, so now we'll talk about the syllabus a bit. And the syllabus is always like really monotonous, so it won't be too long, but I don't think anyone ever really enjoys that. Alright, the syllabus, it's on Canvas, it's on the home page. So you can access it right up top. And it'll open up the file. I'm just gonna use my PDF reader though. So I have a lot of links on here as well that are on the Canvas website. So we have the Zoom link for our lectures, that's right here. It's always the same link, by the way. And then we have, syllabus week is the best week, but it's also kind of boring, So anyways, experiment location, we're gonna meet in the classroom, that's E42, and then we'll walk right over to the lab. We're always going to meet on Fridays at 11:30 a.m. to 2:15 p.m. It's never going to be the full time. Most likely. There might be 1 or 2 labs where it might take the full time, but I doubt it. That's lab 4 and lab 5. And lectures, they never take a long time, so that's, it depends on the material, but it might be around an hour for each lecture. Okay, my office hours are virtual, so they're through Zoom. They're on Monday from 11 a.m. to 12 p.m. I know not everyone is going to be able to make that time, so if you want to go to office hours and you can't make this time, either email me or send me a PM in Discord, which we still need to talk about, and we can set up a different time to meet, or you can just go in Discord and message me there if you find that easier. So let's talk about Discord before I forget about it, actually. Okay, so this class has a Discord server. If you click on this link up here, it's the invite. I think a lot of you are already in there. Okay, so yeah, there's a good amount of you in there. In past semesters, it's been used quite a lot to help out, so definitely take good use of that. If I go back here, we can talk about whatever you want to talk about in the general chat. And then I'm going to have a channel for each of the labs. So for lab 1, if you have any questions, hop in there, ask a question. Hopefully another classmate knows the answer. If you're confused on anything, if you're all confused on something, I'm going to go in there and I'll answer as well. Wow. You had a professor give you a quiz on a syllabus? I think I actually did before too, only one time. It's kind of a little weird. Alright, so that's Discord. If I was you, I would take good use of that because again, people use it often. If you have a question, someone else probably does too, and you guys can get good help there. Okay. Zoom in here. Course description, we already talked about what we're doing in this course. Prereq 225 and 102, I don't know why either of those are prereqs. It seems kind of weird. And then 205, I think most of you have already taken that. That's Matlab. And we're going to be using that in this course. I'll talk about that in a bit. And then 331, some of you are taking that now, most likely, or you've already taken it. All right, textbooks, you don't need any of them. Don't worry about it. The only thing you need is the instructions that I give you. Remember, that's the lab handout from the department. And that'll be online on Canvas. All right, attendance, that's going to be mandatory. I say mandatory, but if you have COVID or any other sickness, of course, don't go to the lab. You don't get people sick, right? If you're sick, send me an email. Don't go. We'll figure out how you can complete the lab. And yeah, so all experiments right now, they're planned on being in person. Who knows though, right? Who knows how this semester is going to shake out. Discord, we just talked about that. This is the invite link again. Okay, grading. So we're going to have 6 lab memos. So we have 6 labs, 6 memos. And that's going to be 80% of your grade. Each memo is going to be weighted the same. And then our final exam, that's going to be 20%. Some instructors for labs, they like having their finals being theoretical, which I don't really get. That's why you're taking that class that is in correspondence with this lab. So you might have 1 or 2 questions on theory where you actually need to do some math, right? But the vast majority of my finals for labs, they're going to be based on what you did in the actual lab. So basically, you don't need to worry about the final at all, as long as you are actually helping, and you're actively involved in the experiment. Okay, I give questions based on that. I'll even still give you a study guide though, so the final should be an easy A. Okay, late lab reports. So so it should be an easy A, but of course that's assuming that you guys actually are active in the experiment. All right, so late lab reports, each day that it's late, I gotta dock 10%, and that'll occur up to 5 days late. Anything after that, it's just an automatic 0. And I'm going to enforce this, right? Because it's hard to grade a lot of lab reports one day and like a week later grade one. You gotta kind of go through the motions again. It's just very inconvenient. So You have 2 weeks to work on each memo, so that's quite a long time. So make sure you get them in on time. Of course, if you're sick or something, you might be a little delayed, so you can still turn it in, but just remember, you're going to be docked 10% each day. I am understanding though, so if you're on a ventilator, right, for weeks, well, you can't do it then. So just let me know, keep me updated on things. If you have things going on in your life, I don't need to know all of the nitty-gritty details, but just communicate with me and I'll work with you. Okay, report guidelines, you're gonna submit them as PDF through Canvas, and I'm going to grade them on Canvas. I'll have the due dates on Canvas, and it's also on the tentative schedule on the syllabus. You gotta type it all. Lab reports / memo. I say report or memo, it's the same thing. They're gonna be done on an individual basis. So you can work on the data processing part, or if you don't understand something, right, you can work with your classmates or ask me questions. But your actual memo, what you type up, that has to be all you. Okay, no copying, no cheating, none of that. And I'm most likely going to use Turnitin as well, just to make things easier on me. But it is usually pretty obvious if you guys are cheating. By that I mean, because I know, right? I took all of these labs. Some people they just copy their friend that took this lab, a few years earlier. They literally just take that report and they turn it in. And that's going to be different data, number one. So it's obvious you cheated. And it's really not going to help you out. So don't do that. All right, so Matlab. I said that that's going to be required for this course. And I know that if I was told this when I took this lab, I would be freaking out. But I don't want you to freak out because I'm going to help a lot with this, at least in the very beginning. I'm gonna give you basically for the first few labs, for sure the first lab, I'll actually give you all of the code, but we're gonna talk about it together as a class. And then you'll continue to use it for all of the other labs, and I'll kind of gradually have you do more work on your own. Now, all of you, I think, should have taken Matlab by now. It says it's a co-rec, but I think you always take that before this class. If I'm wrong, let me know, but that's how it's always been. So unless things have changed, then you've already taken it. So again, we're going to be doing a lot of this together as a class, and I'm doing this not to torture anyone. That's really not why. I think it's going to be helpful for you. So other classes, like kinematics, they often require you to use Matlab for your homework. And just other classes in general, they might require you to use Matlab for like a project or something. Or if you take some classes with Dr. Tran, I just know from experience, a lot of his classes, he uses Matlab. So like computational heat transfer, or some of his finite element classes where you actually write the code yourself, or his computational cardiovascular class, which is a great class. I think we used Matlab a bit there, not too much, but my point is you're going to be using Matlab a lot in your other classes, and maybe, even after college. So this should help you out if you don't feel confident in it. All right, the memo structure and weighting is listed here, so be sure before you turn in your lab report, that you make sure that you covered everything that I have listed out here. Because this is basically the rubric, right? So the abstract, I think a lot of you haven't written an abstract yet for any of your classes. Maybe you did, I don't know. But when I took this lab, I never had written one before. So I was like, what the hell is an abstract? You might know what it is, but you never have actually written one. This is what you need in it, but I'm going to go over how to write an abstract and all of that in more detail, the general rules of thumb. I'll go over all of that in more detail as we approach the first lab. Now this is a very important section. It's 25 points, so I want to make sure you do well on that. The results section, you can see, I don't want to go over, say everything. You can read through this stuff, but Results is going to be the results, and make sure that you actually discuss them a bit in the results section. You don't need to discuss it in depth yet, because that's the discussion section, but really you should be interpreting the data that you're presenting here. So you never want to present a result and that's it, like just put in a plot and then move on. You need to tell the reader, why it's important, what the plot is telling us, all of that kind of stuff. Discussion, you're going to discuss your results in detail, and you're going to have error analysis, whether that is from human error, maybe you messed up conversions for, inches to centimeters, something weird. Never say just human error and leave it at that. That's way too vague. What was the actual error, right? Most of the error that we're going to have in this lab is going to be from equipment failures. Maybe not failures, but issues. So remember I talked about the end fixtures for the column lab? Sometimes those get damaged, and the way the loading is it's not axial anymore. It might be kind of coming in at an angle, and that's going to mess up your experiment. Or maybe the extensometer for the first lab, that might not be centered correctly, which we'll talk about once we get to the lab. But if that wasn't positioned correctly, well, that is human error there. But also you can say that because it was positioned wrong, that it was affecting the results, and this is how. All right, references, that's mostly like a free 5 points. A lot of the labs are going to be referencing some published value for something. So make sure that you have that website or that book, whatever, in your references. The appendix is really for, mostly for sample calculations. So I will tell you what sample calculations you need to have on a handout that I give you. And you just got to do them, right? So that should be a free 15 points too, but it's often not. And I'm always confused by that because I tell you exactly what you need for the sample calcs. Okay, and then formatting and clarity. Basically, is it formatted well? I don't really grade on grammar or spelling because this isn't an English class, although these labs and the lab reports, that's how you get your writing credits. So yes, these labs actually do have something to do with writing. But I won't knock you down if you use the wrong version of to. It'll trigger me a bit, but I'm not going to mark you down on that. All right, lab report format. So this is really just to help you out. You don't need to follow this exactly. Really, I just want to see that your lab is formatted consistently. Something that is important though is captions. So you need to have a caption for every figure that you have and every table that you have. And Microsoft Word, I'm pretty sure you can automate that. So whenever you put in a figure or a table, it will update that figure number or table number automatically. Then you just type in the caption. Okay, so lab safety. For sure you need safety glasses. So if you don't have safety glasses or safety goggles, those are fine too. Make sure you get them before week 3. I'm pretty sure that the Titan shops, they sell safety glasses there, but that was from 2 years ago or something, the last time I was in there. I imagine they still sell them now. The other important thing is wearing closed-toe shoes. So if you have, if you have sandals that you're wearing, you're going to get kicked out. So make sure you wear shoes that are closed-toe shoes every time that we have a lab. And then long pants, I don't think that's enforced, but just to be safe, you should wear them. But I don't think that's ever been enforced. Alright, let's see anything else that's important. If there's any accidents that occurs, you have to report them to me and then also the department. I don't think we've ever had to do that though. Labs always go pretty well. Of course, you need to pay attention. You need to use your brain because you are dealing with some machinery that can do some damage if you're not careful. Alright, if you have special needs, hopefully you've contacted DSS by now. But if you haven't, their phone number is here and their email as well. So call them or email them, tell them what accommodations you need for this class. They're going to contact me, and then I'll be sure to give you whatever those accommodations are. Academic dishonesty, we already kind of talked about that. Don't cheat, okay? Really don't. It's a headache for me, for the department, and it's gonna really suck for you. So don't do it. That stuff is whatever. Okay, and then we have our tentative schedule here. So this is what we have planned for now, but pretty much every semester it changes a bit. So there is some flexibility that we have here. So it always works out. But usually I think sometimes, a lab is delayed, especially with COVID, right? If I get COVID, there's not going to be any lab. Hopefully that doesn't happen. Or if the lab technician gets COVID, I think most likely the lab would be canceled then as well. He's always in there. Well, not always, but a lot of the time. And of course, if you get COVID, you are not going to be able to do the lab that week, and then you'll contact me for how you can make it up. But things are subject to change. If they do change, I will update at least Canvas, and most likely I'll update the syllabus as well. Really, Canvas is your one-stop shop for everything for this class, for the schedule, and for all of your assignments, your grading, everything. The final exam, as of right now, is scheduled for the 17th. That's a Friday. I don't think that should have any conflicts with any of your final exams, but for labs, we're actually not assigned a final date. So it's kind of like up to me to make sure that the final doesn't interfere with anyone. Okay, so that's the syllabus. Any questions on that?
Yeah, Professor, I have a question. As far as the memos, are they due like at midnight, or are they due at the end of the class, or what time are they due by?
Yeah, good question. So the memos, they're always due at 11:59 p.m. officially. So, yeah. If you're a little late, I don't give you a 0 or anything insane like that. If you're like 5 minutes late, you still get full credit. Well, assuming you're not marked down for being late. I'll put it that way. All right, any other questions? Okay, then the last thing that we have to talk about is Matlab. This will take just a few minutes. If you don't have Matlab installed right now, that's okay. Just make sure that you install it, sometime after we do the first lab, because you need to use that for your data processing. Okay. And the instructions for how to get dark mode, I know this is random, but people always like it. The instructions for this, they're also on the slides that I have, but I'm just going to show you just, on the fly. Okay, so we have Matlab opened up, and also if you don't have Matlab, it's free for students, right? Just go to Google, type in CSUF Matlab. There's going to be instructions for how to download it, and you can have it on multiple computers as well. So we're on the Home tab, we click on Preferences. Not Preferences, geez, I wasn't really thinking that. So I was going to say Matlab, they don't have their own built-in dark mode, so we have to get an add-on. So we're on the Home tab, we click on Add-ons. This window is going to pop up. And in this search bar here, we're going to type in Matlab Schemer. So Matlab-Schemer. And then in the first result, that's what we're going to download. Okay, so it's by Scott Lowe. Click on that. And once you go here, you should see on the right-hand side that it should say something like Add to Matlab. And you'll click on that and it will install. So at this point, you can either keep this window open and you can see all of the schemes that they have here, or you can click on Open Folder here. And what that will do is on the left-hand side, it's going to change the folder that Matlab's currently in. It's going to go to the folder where this add-on is installed on your computer. So I'll click on that and you see it just changed. But to use this add-on, you don't need to be in this folder. I'm only doing this so we can see right here all of the different themes that we have. Okay, and to use this add-on, we're going to do, not that, we're going to do schemer underscore import, and then whatever theme that you want. So let's say monoK.prf, press enter, and there we go. There's our dark mode. And this is also applied to our editor. So if we're writing a script, and here we go. This is a comment. Okay, so if we have a section, the section color is also modified. And if you want to go back to the default settings for Matlab, or default colors, right? We're going to do schemer underscore import default.prf. And there we go, everything changed back. Now I want to point something out. We can also change the colors back to default by going to Home, and then Preferences, and Colors, Restore Default Colors, click Apply. So it changed most of the colors, but it didn't change the section color. So to do that, you need to go to Programming Tools, Restore Defaults, Apply, and OK. And there you go. It's faster just to type the command, right? So again, that's schemer import default.prf. So that's dark mode. Unfortunately, up top here, the toolbar, it doesn't change color. It always stays like this. Same with this little tab here. It's always like that too. So that's a little annoying, but that's how it is. If any of you are really interested, you can actually run Matlab inside of a text editor. So let's go to, let's go here. I'm just going to open up some script. This is from a while ago now. Okay, see here, I'm actually in Matlab right here. So I can run this, and this is my command window. I just ran it, and you know, this is nice because everything is dark. So if any of you are interested in that, you can reach out to me and I can help you out with that. And so that's Matlab with dark mode. And with that, I think that's everything I wanted to talk about today. Let's make sure I covered everything. Yeah, okay. So basically what I'll do for lectures, you know, I'm going to stop the recording, I'm going to upload it to YouTube, and then I'll post the link to the lecture on today's page. All right. So are there any questions at all for anything that we covered today, or any questions you have about meeting times, where we meet, or the lab, anything at all? Okay, so if there's no questions, then that's all I had planned for today. So next week, we're going to have our first lecture. And again, that's on Zoom. Remember that. So you don't need to go to school. I'm not going to be there. I'm going to be right here. So yeah, I'm going to update the pictures on Canvas as well so you can see them. But that's all I got for today. So if there's no questions, I'll see you guys next week for our lecture. So have a good weekend. Thanks.
Thank you, Professor.
Yep. See you guys.
Have a good one.
You too.